So, a property like this, guys, 2 plus 3. If 2 plus 3 equals 3 plus 2, this is said to be commutative, okay? A commutative property is a property where the order didn't matter. I'll give you another example. Is 2 multiplied by 3 the same as 3 multiplied by 2? What we can say is that we can now say that multiplication and addition are commutative. Does that make sense? Is 2 minus 3 the same as 3 minus 2? Subtraction is not commutative. Does that make sense? Next thing. Is 2 divided by 3 the same thing as 3 divided by 2? What else can we say? That? Not commutative. Multiplication and addition, commutative. Subtraction and division, not commutative. What does commutative mean? When you turn the numbers around, will it still work? Does that make sense? Still work out the same. If this actually comes into sets as well. So what happens with sets is, imagine this. Imagine we made a set, okay? And we just had 2 basic names like, Mark and Martin, okay? So Mark and Martin are 2 different names, okay? So we call this, they have what letters in common? M, A, and? Or Martin will have T, I, and N. And Mark will just have the K on its own out here. This is set, we call this set capital A and set capital B. Now my question to you guys is this. Is intersection commutative? Is A intersection B exactly the same thing as B intersection A? Intersection is commutative. Everybody got it? Let's try another one. You get the same answer no matter which way they're spun around. What about union? A union B. What's A union B? K-M-A-R-T-I-N. What is so what's B union A? Same thing. What does that mean? Union is commutative. Alright, let's try another one now. Ready? What happens about this? A less B. What does that mean again? Everything that's in A and B. What is everything in A that's not in B? Okay. Everything in B that's not in A. T-I-N. That spells out to me that this is not commutative. Everybody cool with that? Yeah. Okay, going to show you another thing now. The next property we're going to look at is what's called associative. Associative, okay? Now, associative usually involves 3 Venn diagrams, so I'm going to need another name that has some letters in common. Okay, why don't we go for Mary, okay? Actually, Mary's an awkward one. Here, I'll just do it like this, 1 sec. Bring the M down here, bring the A down here, and bring the R there. I can now do Mary as the third one, yeah? Is that okay? Just make things easy. So now we have Martin, Mark, and Mary. Would everybody agree that Martin, Mark, and Mary all have 3 letters in common? Yeah. Now, associative means that you do them in different orders. Associative property would be like this. 2 plus 3 plus 5. Associative means I can bracket any 2 together I want. So example, if I did 2 plus 3 first, what would happen? 2 plus 3 together? 5. And then 5 plus 5? 10. What happens instead of doing 2 plus 3 first, I did 3 plus 5 first. What happened there? 2 plus 8? 10. Addition is, what do you reckon? Addition is associative. What about multiplication? What do you reckon? Is multiplication associative? What happens if we do 2 multiplied by 3 first? 6 times 5? 30. What happens if I go back and instead of doing 2 multiplied by 3 first, I do 3 multiplied by 5 first? 15 times 2? 30. Okay. Let's see if subtraction is associative or subtraction is associative or maybe even division. We'll try division, alright? How about that? 100 divided by 2 divided by 10. Okay. This is going to be interesting. Ready for this? 100 divided by 2. 50. 50 divided by 10. 5. Look at this. 100 divided by 2 divided by 10. I'm going to show you this on the calculator instead. 100 divided by 2 divided by 10. 500. Didn't work out the same, did it? So, which ones I do first matters in division. Do you got it? Is division associative? Is division associative, lads? Division is not associative. Now get this, guys. Yes? It's 2 divided by 10 is a fifth. 100 divided by a fifth. Turn it upside down and multiply like you did in first year. 5 over 1 multiplied by 100. 500. Everybody got it? Do you see the position of the brackets change the answer? Would you agree with that? See the way there were different answers? That means it's not associative. Let's work this using set language. Okay, so let's do this, alright? So everybody, let's go for everything. Let's go for intersection first. Okay? And union second. I'll do union first, actually. Okay, guys. Right, let's try this. Can anybody in class tell me what A union B bracket union C is? Yeah. Okay. Everything that's in A and B, yeah? That's A union B. You got it? And then what's union C as well? Or C. So, is everybody happy that's the full thing? What happens if I move the bracket slightly? What happens if instead of doing A union B union C, I do A union B bracket union C? Have to do B union C first, because it's in the brackets, correct? Das. So what's B union C? Would everybody agree that's B union C? Yeah? And then union, then A unions with that? So, same answer, correct? Yeah. Great. Let's look at this one. Now, what happens if I do, so everybody would say that union is a associative. Everybody cool with that? Union is associative. No bother. Next thing. Is A intersection B? What's A intersection B? Intersection B, guys? Oh, this is unfortunate. Can I change my name to Marky with an I?
Joe.
Oh, wait. Can I change my name to Marky with an I? Because this is just an unfortunate example, okay? So the three names are now Marky with an I. Alright with that? Martin. I just had to change it for this example, otherwise it's just an unfortunate example. What's it, Mary? Actually, gonna change it to... no, we'll go with... Actually, no, Melissa won't do it. Okay, can I just change it to Marky with an I? So what does that do to this I here? Huh? So it goes into there then. Is that okay? We good? Now I'm going to show you something. First of all, what's A intersection B? Now, what is A intersection B now? I, A, R, and M. Intersection C. It also has to be in C. So which part is also inside of C? Your answer would be A, R, and M. Look what happens when I move it. Okay, I'm going to move it again. This time I'm going to do A, A intersection B intersection C. So what do I have to highlight first this time? B intersection C. And then it also has to be in common with, what does that have to be in common with? A. So it's the same answer, isn't it? A, R, and M. So is everybody happy that intersection seems to be associative? Let's try less. Let's try the other one. Okay, let's try this one out. Let's try. Okay, I think this one will work. I think this one won't work more so. Okay, everybody look at this. A less B less C. Everybody ready? What does A less B mean? Everything in A that's not in B. What's everything in A that's not in B? K. It's also not allowed B in. So the answer is simply K. Let's rearrange this now for another answer. What about A? Everything in A, but you're not allowed B in B less C. See the way I just moved the brackets?